This lesson comes out of lesson 4.3 in Math 20, solving quadratic equations by completing the square. And our goal here is to solve this quadratic equation by completing the square. Now, it's worth noting here, completing the square is not the most efficient way of solving a quadratic equation. We could graph this and find its zeros. We could also use the quadratic formula that we'll learn in 4.4. There are some faster ways of doing this one, even though it doesn't factor nicely, than completing the square. So the only time I want you to complete the square is if the question says, by completing the square. Now, remember what a completed square looks like. That, if I had x plus 5 times x plus 5, which is x plus 5 squared, it ends up being x squared plus 10x plus 25. We did some of this back in 3.3, so if you need a quick refresher on what a completed square looks like, we did do some of that in 3.3 as well when we were converting parabolas into vertex form. But so I'm going to follow a very similar set of steps for this question. Remember, my first step was to move my constant just kind of over and out of the way, away from the x terms. Now I'm going to factor out whatever coefficient was in front of x squared. In this case, it's a 2, so I factor it out of the x terms. Again, leaving that minus 3 alone. Now I want to say in those brackets, what would I need to make that a perfect square? And the answer is half of 10 squared. So half of 10 is 5, 5 times 5 is 25. If I had a plus 25 in there, I'd have a perfect square. So what do? I invent one, I create one. I put a plus 25 in there, but just so that I don't change the value of anything, I also put a minus 25 in there because 25 minus 25 is 0. I haven't changed the value of my equation. Now I'm going to leave only the perfect square in the brackets. So I'm going to leave that plus 25 in the brackets, but I have to take the minus 25 out of the brackets. And to do that, you've got to multiply by 2. That's kind of the bouncer gatekeeper of those brackets. So now what we've done is we're able to say, okay, well, that's x plus 5 squared. We've got 2 times x plus 5 squared minus 53 equals 0 in this case. Back in 3.3, that would have equaled y, and we'd have it in vertex form. We'd be done our question. But now we got to remember what we're trying to do here. We're trying to solve for x. So we're not actually done, but we've put it in a form that we can actually do it. So the first step in solving for x is let's move that 53 to the other side. We got to add 53 to both sides, and we have this. Next, I'll divide by 2. So I've chosen to leave this as a fraction. You could write it as 26.5 if you like, but I've got x plus 5 squared equals that, 53 over 2. Now I take the plus or minus square root of that. So I get rid of the squared sign, in other words. I say, okay, well, x plus 5 then must either be the positive square root of that gross number or the negative square root of it. And so finally, the last step is to subtract 5 from both sides, and what you have, notice this is 2 answers. You've got negative 5 plus the square root of 53 over 2 and negative 5 minus the square root of 53 over 2. And there is one good thing about solving it this way, is that this is an exact value answer. This has not been rounded. Had I done a second trace, find the zeros of this parabola in the first place, I would get decimal answers equivalent to this, but I wouldn't be able to get this square root type of answer. But what you'll see in the next lesson, 4.4, is that you can get exact value answers in quite a bit faster way. This is probably the most algebra in one question that a Math 20 has ever seen, to have to complete the square and solve for x. So very challenging questions. Do some practice in 4.3 and definitely ask as you run into any difficulties on these ones. You would not be alone.